Hello everyone, and welcome back to another exciting physics video. Today we're going to go over what we've done in the last few days, at least for most of you, which has been dot diagrams. So just to do a recap, dot diagrams are a sort of another representation of motion and how we can represent something that is moving. In class you used a ball, such as a bowling ball, rolling down the floor, and every couple of seconds, right, someone had their stopwatch. This is an old-fashioned stopwatch that you weren't using, I'm sure, but you used a stopwatch and counted off seconds, all right, and then another person would throw down sugar packets or make marks on the floor for even distribution of marks on the floor to show where the ball was at a given moment, right? And so using this idea, what we can do is we can say, well, if we, instead of using the sugar packets, we just represent these with dots, what we end up with is a representation that looks something like this. And so this is one example of an object, of tracking the motion of an object with a dot diagram. Now, if we had an object moving faster, as you should have seen in class, what will happen is these dots will become further apart, right? Resulting in sort of fewer dots in the same distance, or just dots further apart. And then similarly, if you had a slower object, the dots would be closer together. Now, this dot diagram is great, but there's one problem. We don't have any indicator of direction. Right now, all we have is relative motion. So if you have two dot diagrams next to each other, you can tell, well, this one is slower than this one, but faster than this one, right? So there's no way to tell direction here. And so there are several ways that we can decide what the direction, or how to indicate direction. The way we are going to do is sort of like you did. You decided, okay, well, let's put a start here. Right? So why not do the same thing here? Let's have a start here. Okay, so now you would put a start where you want the starting one to be, and now you know that they're all moving this way, right? Now there's some sort of indicator of direction that basically sums up that. So now we have an indicator of direction, so if it started here, it's obviously moving this way, and we also have the relative speed, which were all the parts of the dot diagram that I wanted you to have. Let's look at some other examples quickly. So let's say we have two dot diagrams. One dot diagram that looks like this, and one dot diagram that looks like this. Okay? So think to yourself, what is the difference between these two dot diagrams? Okay? If you need to pause the video, I'll give you a minute to pause and take a minute to think about what these two dot diagrams are telling you. Okay, you should have paused. Hopefully you realized that this dot diagram is moving with a constant speed, right? The same distance is covered in each time interval, whether it be 1 second or 2 seconds. And this one is changing in speed, right? We'll do a little bit more about that a little bit later. But for now, just realize that this can't be constant because this distance is covered in 1 second, but then this distance is covered in 1 second, and then this one and this one. So it's changing. Now, if you said that this object is slowing down, you could be right, but I never said where the object is starting. If you said it was speeding up, you could also be right. If you put the start over here, then the object is obviously speeding up. It starts slow and the distance gets bigger, so it gets faster. Or if the start is over here, then it is slowing down because it starts off big and then starts getting smaller. Okay? So let's look at a few problems now that we have this idea. So here's your first problem. Meg created a dot diagram for a bug she found on the ground. Use a dot diagram to describe the motion of the bug. Is it moving at a constant pace? Is it speeding up or slowing down? Explain. So now you are going to pause the video, and this is going to be your homework for tonight. Answer this question, and there's going to be another one after this. So pause the video, copy the question down, and answer it the best you can. Okay, now that you've copied that down, let's move on to the next question. The dot diagram for two bicyclists are shown below. When were they at the same location at the same time? Now remember, each of these dots represents, each consecutive dot represents one time interval. So from here to here is 1 second, from here to here is 1 second, from here to here is 1 second. Similarly, from here to here is 1 second, from here to here is 1 second, from here to here is 1 second. So be very careful when answering this question. Where were they at the same location at the same time? Same location, same time. All right? Take a minute to copy down this problem, and I'm going to stop the video here. Turn in these two problems with your quiz tomorrow, and I will see you then. Bye.